So we'll just be dealing with the first the first learning objective from this particular section. So I'm going to re-explain this at the end, but linear transformations are basically if you are going to be adding some number to your original stuff or multiplying some number by your original stuff being x, and you get some resulting amount, it's considered a linear transformation. So we studied linear transformations in chapter 2. We didn't call them that, but that's what they are. So what we did find though, and we're going to talk about this in class, is that when you have some number and you're going to add that number to each observation, that affects all of the location measures. The measure of center, the Q1, the Q3, the minimum, the maximum increases by A or decreases by A if A is a negative number. But it doesn't change the shape or the measures of spread. However, when you multiply or divide by some number, this constant b, that if we were dealing with an actual line, it would be your slope, that affects the measures of center by b and the measures of spread, IQR, your range, your variance, your standard deviation, they're all affected by b. And when we're dealing with the measures of spread, it's always a positive value. It's considered as an absolute value. And then, once again, your distribution does not change. Here we're going to start by looking at multiplying by a constant. So let's look at the probability distribution of a situation of a company that offers half-day trips. And they have to have at least 2 passengers, and that's a 15% chance that they run a trip with 2 passengers, all the way up to 6 passengers, in which there's a 5% chance that they're going to have a full trip. So we define x as the number of passengers on a randomly selected day, and when we find our average, 2 times 0.15 plus 3 times 0.25 times plus 4 times 0.35, etc., we find out that the mean is 3.75. And remember, we don't round. We just say that after many, many days, we can expect to have about 3.75 passengers, and the standard deviation is about 1.090, or about 1 passenger a day. If we're talking about how much money he collects per passenger, that means we're going to multiply everything times 150, so that 2 passengers becomes $300, which is what we're making, and the 3 passengers becomes $450, and the 4 passengers $600, etc. And the probability stays the same. So once we do our calculations, we're going to find out that the mean of 3.75 times 150 is going to be $562.50. The new mean is 150 times more than the old mean, because that's how it rolls. And then the standard deviation is also 150 times bigger than the original thing. So it would be 1.090 times $150 per passenger. So our variation is going to be $163.50 on a typical day. And notice that the distributions look very, very similar. One's in gray and one's clear. But the shape is very much the same. And pretty much the only thing that's different is how we've scaled it and the label. And so when we multiply by random variable, so multiplying by some constant, so once again in our linear transformation, this would be the bx part, this part. We find out that when we multiply or divide by some number, it affects everything except the shape. It affects every measure of location, the center, the minimum, the maximum, all of it by that number. And then the measures of spread, all of them are affected by that absolute value of that number. So now we're going to be looking at adding a constant. So if we're talking about the linear transformation here, we've already dealt with what happens when you multiply by everything, every data point by a certain number. Now we're going to look at what happens when we add a constant. So we're talking about, this is how much Pete brings in, right? $300, 15% of the time, $450 a day. 25% of the time, and the mean was 562.50, and the standard deviation was 163.50. Now, if it costs Pete $100 a trip, not counting paying Pete, then his profit's going to be $200 15% of the time, $350 25% of the time, etc., etc., etc. And when you go ahead and calculate the new mean, you're going to find out that it is $100 less than the collected money. And the standard deviation, on the other hand, isn't shifting. It still varies by $163 every day. The pictures are exactly the same except for this. So remember, when you add, the shape of the distribution is not changing. This is just a little fatter. That's not really the big deal. But the center is about the same place. The minimum, the maximum, about the same place. Except it's just a different number because we're talking about different scaling. So once again, adding a constant, that's going to add only to the location measures. Measures center, Q1, median, blah, blah, blah. But adding does not change the measures of spread, any of them. And in this particular chapter, we're only talking mostly about variance and standard deviation. The shape of the distribution is not affected by multiplying or adding. So, once again, linear transformations, it all looks so whack-doodle, but it's not that big of a deal. So basically, notice how this time we've got, and I'm going to blow it up so you can see it, the x is a big ol' x, and the big ol' x means it's a random variable, some sort of random situation. And the probability distribution of y has the same shape as the probability distribution of x, whether you've added the same number to each piece of x or whether you've multiplied by the same number of each piece of x. And look at this collection of joy right here. The the mean of x is going to be affected by all this craziness means is the mean of x is affected by the adding and the multiplying, and the standard deviation of x is only affected by the multiplying. That's all that says. Even though it looks like a whole load of bananas, it's really not that big of a deal once you get used to it. And this just basically summarizes what these are the words that go with this stuff. So this explanation is that word explanation. By the way, this is true whether you're dealing with data, random variables, all are the same, and it works with discrete and continuous random.